Hello, my name is Peter, and in this presentation I will update you on the automotive e-mobility and specifically development in hydrogen mobility in Slovakia. I work as a consultant in Slovak Investment and Trade Development Agency Investment Project Department, and if you are considering investment in Slovakia, opening up a factory or offices here, or are looking for a component or solution supplier, we are the guys to talk to. If we have a closer look at the broader region of Slovakia, the automotive sector plays a vital role in the economies of Central European countries. Annually, they are producing more than 4 million of passenger cars. Since the last 2 decades, the number of car plants has increased from 8 to 35, and already there are 3 car plants announced, that means in a ramp-up phase, and many of the OEMs are considering e-mobility products. The utilization of greener mobility in Slovakia is inevitable, as for the rest of the world. According to McKinsey, by 2040 the battery demand from EV produced in Europe will reach a total of 1200 gigawatt hours per year, which is enough for at least 80 gigafactories with an average capacity of 15 gigawatt hours per year. There are at least 10 battery manufacturing brands already confirmed in the neighbor region, and this is opening up promising perspectives to the Central Europe and Slovakia. Now let's have a closer look at Slovak economy specifically. Slovakia is one of the most industrial countries in the whole European Union, with a 34% share of the industry on the economy. The key pillars of Slovak economy are automotive and machinery, electronics, and ICT and business service sector. The cross-sectoral cooperation and strengths are also vital for development of e-mobility. As you can see on the slide, the automotive industry has a significant footprint on the Slovak economy, representing half of the industry output and directly and indirectly employing around 280,000 jobs. We have 4 vehicle producers in Slovakia, and all of the OEMs are producing in some way electrified models. Altogether, there are 20 electrified models produced in Slovakia, and 4 of them are purely battery electric vehicles. It is well known that Slovakia is the world leader in car production per capita. Annually, we are producing more than 1 million cars per year, and e-mobility is not a world from the future for the Slovak. It has already gained a major presence in Slovak economy. The statistics and forecasts are undeniable. The share of alternative powered vehicle on car export increased from 1% in 2018 to 24% in 2009. Also, we have by far the highest forecasted production of electric vehicles in Europe for 2025. And 4 of the OEMs, Volkswagen, Stellantis, Kia, JLR, have plans to produce EVs at a large scale in the future. More than 350 automotive suppliers are operating in Slovakia. The vast developed supplier network was also one of the key reasons why Jaguar Land Rover decided to place the plant in Nitra. Many of the suppliers are already active in the EV market and also other e-mobility power sources. For example, the Slovak company Rochero has developed and already producing fully electrified and hydrogen-based minibuses. From the perspective of security of the battery production in EU, it is important that we do not rely only on manufacturers from abroad, but have our own developing and production alternatives. And such an alternative is the Slovak company Inobat. Inobat could be seen as the EU's in-house EV battery solution developer. Also, an important role in the Inobat Group portfolio has Inobat Hydrogen. Their product Inobat Station is an innovative multifunctional portable battery and hydrogen energy storage system which can be used also as a refueling station for electric vehicles. Slovakia's National Battery Center is representing a hands-on approach and cooperation between the Slovak Academy of Science, Slovak Research, universities, and industry stakeholders. Their main goal is the development and production of advanced batteries and technologies, including new types of batteries, and also practical testing, validation of the new technologies with industrial partners, and ensuring that the technologies and solution would also see the light of the day in the industry. And not forgetting the training of young talents and specialists competitive in the environment of innovative battery technologies. Many specialist policymakers see the electric batteries in the mobility as much needed but only a preliminary milestone or a phase towards more effective and greener source to decarbonize mobility. And the final step or the solution for it could very be the utilization of hydrogen. The global energy demand supplied with hydrogen is increasing. In the next 30 years, it could increase to a sevenfold, and the increase will show mainly in the transportation, industrial energy, or building, heat, and power sector. There are already 30 countries with hydrogen roadmaps and more than 70 billions of public funding by the government worldwide is investing into hydrogen technologies. The European context and the EU strategy for a climate neutral Europe plays a huge role for the hydrogen development in Slovakia and all Europe. The strategic objectives says that in 2024 there will be a production of up to 1 million of tons of renewable energy to decarbonize existing hydrogen production. And the production should even increase to 10 millions of tons of renewable hydrogen energy till 2030. Of course, everybody knows that hydrogen technologies needs to mature in order to be really utilized and deployed at large scale. But the estimation says that till 2015 there will be 1 million of people employed directly and indirectly in this sector, and 13 to 14% share of hydrogen in Europe's energy mix will be a reality. The first steps have already been taken to develop Slovak hydrogen ecosystem. The first milestone was definitely the creation of national hydrogen strategy. It is promoting the cooperation with industry, R&D, and educational institutions. It is creating the legislative framework and the policies to stimulate the demand for hydrogen and implementing a support mechanism for development and production of technologies, components. In Slovakia, the hydrogen could be used in different industries, mainly in chemical industry as a raw material or chemical substance, also as an energy carrier in energy intensive production, in glass production or metallurgic industry. Another good example is steel industry, where it can be used in a steel production as a substitute for coke, or direct reduction of iron ore, replacement for high emission blast furnace technologies. And nevertheless, the mobility in the transportation sector and the public transport vehicles, long distance trucks, trains, machinery, and fuel cells in passenger cars, an alternative to internal combustion engines and battery electromobility. There are numerous companies in Slovakia who are already involved in hydrogen technologies. Just to name few of them, Slonav and Dusel, the both companies are involved in production of hydrogen in the power to gas technology for internal consumption. Nafta is a project focused on storage of energy in underground geological structures in the form of natural gas and hydrogen. Just recently, the Hydrogen Technology Research Center was established in the second largest city of Slovakia in Košice, with the aim to integrate all hydrogen-related research and development activities in Slovakia. The center has three founding members, the first member being Technical University of Košice. The university has more over 13 years of experience with hydrogen technologies, dedicated in the Hydrogen Technology Lab. The second member, Pavel Josef Šafárik University in Košice, is developing hydrogen absorption materials, and the third member, Institute of Material Research in the Slovak Academy of Sciences, is developing materials with high hydrogen storage capacity. E-mobility, the development of electric batteries, hydrogen fuel cells, could be seen as an opportunity and as a catalyzer of the ongoing process of transforming the manufacturing assembly-based economy towards more added value and knowledge-intense economy. Subsectoral cooperation and cooperation between the universities, R&D institutions, and companies as Innobat, Rochero, hands-on approach and support by the government is crucial for Slovakia in order to catch the new trends in automotive sector, but also in industry as such. Thank you for the attention, and may you have any other question, please do not hesitate to contact us.
Hello everybody, today I want to show you the roadmap to a carbon negative hydrogen gas production and the on-site renewable gas technologies that we have developed at HyGear to accelerate the transition to a low carbon economy. My name is Gerard, I'm the regional sales manager for HyGear based in Singapore. So HyGear is part of Zeebeck Absorption Group, and our vision at Zeebeck as a company is that we want to power the world with clean energy. To do this, we have a mission to transition to a low carbon future by accelerating the development of renewable and low carbon gases. So Zeebeck is a provider of clean energy solutions, and we make systems that generate and recover renewable gases that are used in the energy, mobility, and other industrial applications. So our headquarters is located in Quebec, Canada. In North America, we have multiple service centers and manufacturing facilities to build our system. The Hydrogen Center of Excellence and Hydrogen Production Center of Excellence is located in the Netherlands at the headquarters of HyGear. So within the Zeebeck Group, we have a unique complementary technology base. One part on the left side, we have the gas upgrading and the gas cleaning segment. So we use upgrading technologies to upgrade biogas to renewable natural gas, renewable gas that can be used to decarbonize the gas grid. And next to that, we have gas purification technologies for hydrogen, argon, helium, and nitrogen gases. On the right side, we have the hydrogen production technologies. These are for hydrogen gas, oxygen gas, and nitrogen gas. We are a technology neutral company, so we have steam methane reformers. Our key cornerstone product is the containerized and modular steam methane reformer, which has been operational since 2010. But we also have alkaline electrolyzers to produce hydrogen from electricity. Important to notice that we are really technology neutral. We have all the technologies available within the group to offer the most green hydrogen gas solution for your situation. So industrial hydrogen gas production today, majority of hydrogen gas produced today is through steam methane reforming, large centralized plants, because steam methane reforming is the most matured and efficient technology to produce hydrogen gas today. A lot of these steam methane reformer plants, almost 100% is fossil fuel based. Majority of them are from natural gas or from oil off gas reforming, which is also for the most part methane gas. 18% of it is coal gasification, and 4% of the hydrogen production globally is through electrolysis. One thing to note here is that the electrolysis-based hydrogen gas is not from water electrolysis, but it is the byproduct from the chlorine production process. So water electrolysis only has a small share in the total world production. So what is the current hydrogen gas supply chain? Why should you generate gases on site? Well, the traditional method is a centralized production location. From there, you compress and transport the gas to the end customer. By generating gases on site, you eliminate the need for additional compression and storage, but also eliminate the emissions that are related to those processes. Because compressing and transporting of hydrogen is really inefficient. You have to put in a lot of energy, and the amount of hydrogen that you can store in a truck is very limited. And the emissions that are associated with the trucking of gas, the CO2 emissions and NOx emissions and particle matter emissions are also increasing the environmental impact of the hydrogen gas. So let's talk about the colors of hydrogen. There's a lot of talk about the colors of hydrogen today, so I think it's important to quickly go through them. Gray hydrogen on the left is produced from a fossil fuel source, and this can be produced in two ways: by using natural gas in a steam reformer, or you can use electricity from the current electricity mix. In most countries, the electricity that is produced is derived from fossil fuel sources, and the hydrogen that you produce from this electricity is considered gray. Then one step to the right, we have blue hydrogen. It's used the same production technologies as gray hydrogen, but you capture the CO2 that is combusted or that is produced in the process, resulting in a zero CO2 emission production process. But your feedstock is still fossil fuel based. Then we go to green hydrogen. Green hydrogen is powered by renewable energy. Renewable energy does not only consist of solar, wind, and hydropower, which is the main driver for electrolyzer production cost today, but you also have biogas. Biogas is also a renewable energy source produced from carbon organic waste that is already present in the atmosphere today. And if we use these renewable sources to produce hydrogen gas, we have a net zero carbon emission hydrogen gas. So what is cyan hydrogen gas? Cyan hydrogen gas is a combination of green and blue. So if we take a renewable feedstock source like biogas and we use carbon capture technologies to capture the CO2 that is produced in that process, we take away CO2 from the atmosphere, which results in a carbon negative hydrogen gas. So one key takeaway here is that the production technology itself does not determine the color of hydrogen. If you have a green fuel, you will get a green product. If you have a gray fuel, you will get a gray product. By using carbon capture technologies, you can change the colors of hydrogen. So gray becomes blue and green becomes cyan. So green hydrogen production from organic waste. This is the flow chart. So we have containerized on-site modular hydrogen gas production and biogas upgrading solutions. Biogas can be produced from organic waste sources such as cow manure, food waste, and agricultural waste, or biogas from wastewater treatment plants. CBEC has developed a containerized technology to upgrade biogas to renewable natural gas, which is almost pure methane. We can use renewable natural gas in our conventional steam methane reformers. So on this picture, you see the HyGear containerized and modular steam methane reformer, the HyGen technology. And if we use renewable natural gas in steam methane reforming, we produce a green hydrogen gas with zero CO2 emissions. Then how can we make this even better? How can we produce a cyan hydrogen? That is by capturing the CO2 that is produced in this process. So if you have biogas as a feedstock, you upgrade it to renewable natural gas, and you use this gas to produce hydrogen gas, you already have green hydrogen gas. But by capturing the CO2 from the biogas upgrading and also the hydrogen production process, you remove CO2 emissions from the atmosphere, and therefore you result in a carbon negative, in a net negative CO2 emission hydrogen gas. So what does it cost? After looking at the colors and the production methods, also good to have a look at the cost, because it's a common question from our customers, and it's a very important one. So these are the utility cost comparison for the production of 1 kilogram of hydrogen gas. So a natural gas steam-based steam methane reformer consumes 4.1 cubic meters of natural gas per kilogram of hydrogen. The average industrial natural gas price in the US is $3.9 per MMBTU, which results in a total production cost of 57 US cents. If we use renewable natural gas, we can use the same technology and we consume the same amount of natural gas per kilogram of hydrogen production, but the prices of renewable natural gas are higher. The price for this gas depends a bit on your region and the location where you are. It ranges between $2 to $20 per MMBTU. So I found that the average price is $7.8 per MMBTU, which result in a hydrogen gas price or a utility cost price per kilogram of hydrogen of $1.15, which is 2 times more expensive than the normal natural gas price. Then if we have a look at electrolyzers, standard electrolyzer uses 55 kilowatts per kilogram of hydrogen gas. So if we take an electricity price, an average industrial electricity price in the US of $0.07 per kilowatt, excluding any additional grid fees, the total production cost of hydrogen gas is $3.85 per kilogram. So if you compare this 3.85 with the traditional natural gas-based steam methane reforming, you can already see why steam methane reforming is the technology that is widely used in the industrial gas market today, industrial hydrogen gas market today, because it is 6 times more expensive to use electrolysis-based hydrogen production. So what I want to show here also is that if you use renewable natural gas in steam methane reforming processes, you still are 3 times less expensive compared to the electrolysis systems that are available in the market today. So these are only the utility costs. Then if we have a look at the total cost of ownership, you can see that the capex prices of all the technologies are somewhat similar. The key differences are in the operating cost. So for the natural gas with no carbon capture storage, which is $1 per kilogram, if you want to apply carbon capture as storage, you increase the costs by 50%. Then using renewable natural gas in traditional steam methane reformers, you're in the same ballpark range as natural gas with carbon capture. And the key driver is the cost for your renewable natural gas. Using renewable natural gas with carbon capture and storage solutions, so basically producing cyan hydrogen gas, will result in a carbon negative hydrogen gas, but it comes with a price as it is almost twice as expensive as your conventional natural gas production method at $2.1 per kilogram. Then if you take a look at the electrolyzer, you see that the capex is pretty competitive, but the operational costs make it so that the hydrogen price from an electrolyzer is $4.5 per kilogram. So again, here you can see why natural gas-based steam methane reforming is the most used technology today and is the most mature technology. Of course, we should be moving to the right with more renewable hydrogen gas production methods, and legislation can play its role to push companies to look at more renewable sources. So what are the conclusions? The conversion technology, the hydrogen production technology, does not determine the color of hydrogen gas. It's all about carbon emissions. So if you use a green feedstock, you will get a green product. If you use a gray feedstock, you will get a gray product. By using carbon capture technologies, you can change the color of hydrogen gas. So from gray hydrogen, you can produce blue hydrogen, and from green hydrogen, you can produce cyan hydrogen. So hydrogen today, steam methane reforming is the most environmentally friendly and lowest cost production method of hydrogen today. Is this sufficient to battle climate change? No. We need to step up and take actions to reduce our footprint and use more renewable sources and carbon capture technologies in these traditional production methods to go to net zero or carbon negative emissions. So the best method of going green tomorrow will be by using renewable natural gas and or carbon capture technologies with existing facilities. Beyond tomorrow, I think it's very important to lower the carbon intensity of the electricity mix, of the electricity grid mix, so that electrolyzers can become cost competitive or on an environmental perspective with steam methane reformers, but also lower the price of electricity to produce hydrogen gas at a competitive cost. So I think for policymakers, it's really important to invest more in renewable energy and make sure that electricity gets greener, and that the gas grid gets greener with renewable natural gas, because essentially these are the two feedstocks for hydrogen gas to succeed as a renewable gas. And hydrogen is the fuel of the future, so this needs to happen. So if you want to reduce your carbon footprint, invest especially in renewable energies. So that is what I wanted to share with you today. For more information, feel free to reach out to me directly or at my colleagues at HyGear or CBEC, and we'll be of help. Thank you.
Hello and welcome to my presentation. My name is Simon Fraser and I work as Global Program Manager for Fuel Cell Test Systems at AVL in Austria. It is my pleasure to contribute some thoughts about accelerating development and validation of fuel cell systems to the Hydrogen Mobility and Energy Show 2021. A few words about my background. So after graduation, I spent a total of 6 years doing research and development on polymer electrolyte membrane fuel cells and hydrogen production in the Kristian Doppler Laboratory for Fuel Cell Systems in Austria. I also got a PhD for work on PEM fuel cells back in 2004. I joined AVL in 2014 and have worked in AVL's Instrumentation and Test Systems division since then, since 2018 with a focus on test systems for fuel cells. We at AVL are the world's largest independent company for the development, simulation and testing of powertrain systems. We are active in all different types of powertrain systems, but since the focus of today's presentation is on fuel cell propulsion systems, please let me briefly summarize our expertise and our offering for fuel cell and fuel cell electric vehicle development. AVL's Advanced Simulation Technologies division offers detailed multiphysics simulation tools for cell and stack design, as well as system and vehicle level simulation tools. AVL's Powertrain Engineering division develops fuel cell stacks and fuel cell systems, and also has a lot of experience in vehicle integration. And finally, the Instrumentation and Test Systems division offers a very extensive portfolio of measurement, instrumentation and test systems for the development of fuel cells and fuel cell electric powertrains in vehicles. I personally work in the Instrumentation and Test Systems division, and this will also be the focus of my presentation today. AVL as a company is well known as a technology and solution provider for the automotive industry. However, please keep in mind that fuel cells are not just a topic for the automotive industry. Many of our fuel cell projects are for customers working on heavy-duty applications. We also have projects with customers from marine and aerospace industry, even stationary applications. So the points I will present in the following are therefore widely applicable across all different fuel cell applications and industries. So the key question of today's presentation is how can we accelerate development and validation of fuel cell systems? And as you might expect, there's not just one answer for this, but I would actually like to offer 3 answers. And the first answer I would like to offer is that development and validation can be significantly accelerated by using a consistent product development toolchain. What do I mean by saying this? So let's assume we want to integrate a fuel cell system into a fuel cell electric powertrain or vehicle. The starting point of such a development will typically be in office simulations. Then we will typically go onto a special hardware-in-the-loop environment we call virtual test system. The only hardware available at this point is the control unit. We interface this control unit to models representing the missing powertrain components, and we emulate the sensor signals the control unit receives. An interesting setup to start calibration work. Then we will move on to a fuel cell system testbed, where the fuel cell stack and the balance of plant components are jointly operated for the very first time. Fuel cell system testbeds therefore play a very critical and important role in bridging the gap between stack development and system integration. And finally, we go to higher integration levels, first testing the powertrain on a powertrain testbed, and finally the complete vehicle on a chassis dyno. Working on a comparably new technology, such as fuel cells, makes one point particularly important: consistency. Yeah? What does this mean? This means being consistent in the models, in the parameters, and the results data we use and we generate. Yeah? And this across the different simulation and testing environments. As an example, using models previously applied with an office simulation, also with the co-simulation application on a fuel cell system testbed. It also means being consistent in the tools we use, using a common host system, the same test automation system across all testing solutions, consistent pre- and post-processing tools from component to vehicle. So very important, consistency empowers data, easy data access and reuse. So it increases development efficiency. Yeah? So the first answer to the question, how can we accelerate development and validation, is by checking if our tool chain is consistent. The second answer I would like to offer is that one can accelerate development and validation by using advanced development methodologies. So when we talk about testing of fuel cells, we very often talk about the testing summarized on the left-hand side of this slide. Yeah? So screening and selecting components for stack and fuel cell systems, for instance, performance testing, investigating degradation and robustness. This kind of testing is typically done in research, but of course also in pre-development and in development activities. Yeah. When we talk about development of fuel cell powertrains and vehicles for serious product production, however, we have to go one step further. Yeah? For example, we have to test the fuel cell system under realistic operating conditions. Operating conditions the fuel cell system would be exposed to when operated in the real vehicle. This does not just refer to ambient condition, but it also means that we have to consider the interaction between fuel cell system and other powertrain components, such as the battery or the electric axle. We could certainly investigate this in a pure simulation environment, and we could test this with a complete powertrain or vehicle prototype. What I would like to briefly show on the next slides, however, is how this can be done using the concepts of front-loading and co-simulation, so advanced development methodologies. So let's consider the following setup. Let's assume we want to work on powertrain operating strategies for a fuel cell electric vehicle. We have a prototype of the fuel cell system, but as shown on the right-hand side, we do not yet have prototypes of other powertrain components, such as the e-axle and the battery. Yeah? So the question is, despite not having a complete powertrain, can we nevertheless use our fuel cell system prototype to work on operating strategies? To be precise, can we front-load powertrain development tasks onto a fuel cell system testbed? Here's how we can do this using AVL's seamless development toolchain. So we're going to start in the real world, where we have a fuel cell system, a prototype, being operated on the fuel cell system testbed. We do not have physical prototypes of batteries and e-axles, so we have to move into the virtual world, which is shown on the left-hand side. And we use models of the missing powertrain components to simulate their behavior. So for instance, we're going to simulate how much power the e-axle draws from the high voltage bus to provide the torque requested by the driver. We use the AVL tool testbed connect to interface the powertrain component models to the test automation system Puma 2 fuel cell. If we want, we can also interface a driver and vehicle simulation tool. We can also, of course, use a common host system for central management of parameters and results. We can use a post-processing tool such as Concerto for automatic report generation. And what we now have is a setup where the powertrain component model shown on the left-hand side can be used to define the operating conditions of the fuel cell system via the fuel cell system testbed, which is shown on the right-hand side. So what is the benefit of having this kind of setup? First of all, we can operate the fuel cell system on the testbed with very, very realistic operating conditions. So for instance, the fuel cell system output power can be defined as a function of the demand. So this means the requested road maneuver and the specific vehicle, as well as the output power of the battery and the power demand of the electric axle. Secondly, we can reduce the dependence on prototypes. So physical prototypes, they're expensive. Nobody wants to damage a valuable prototype in testing. And a prototype cannot be simultaneously operated on multiple test beds. Using a model, all of these problems can be avoided. And finally, we can speed up development. We can do development tasks before a complete prototype of the powertrain is even available. So front-loading via co-simulation provides quite a few advantages, and accelerating development is one of them. The third answer I would like to offer today is that the choice of the right testing solution does have a significant impact. When choosing the right testing solution, we first have to decide what we want to do. If we want to do performance or durability testing, an integrated testing solution may be a very good fit. An integrated solution, as shown on this slide, integrates testbed functionality into one common frame. So you can see a close-up of AVL's CCSM, the combined conditioning, supply and measurement unit on the right. Such an integrated solution is compact, has a small footprint, only a few interfaces. It's easy to install, easy to relocate, but the possibilities of upgrading this testbed are limited because it's an integrated solution. A modular testing solution, on the other hand, consists of multiple testbed modules. So each testbed functionality is covered by an individual module. There's going to be one module for hydrogen conditioning and consumption measurement, one module for stack coolant conditioning, another module for treating exhaust gases, and so on. So we'll have a number of testbed modules we have to position in our test cell. The big advantage is that we have a very high degree of flexibility and upgradability if we go for a modular testbed. So let's assume we have a modular testbed in a basic performance testing configuration. Adding an intake air conditioning module, a climatic chamber, and a dedicated exhaust module will upgrade this performance testbed to a climatic testbed. And we're ready to do environmental testing, free startup testing, for instance. We can also upgrade a modular performance testbed to support altitude simulation. We can add modules to support NVH testing, co-simulation. We can add an advanced degradation toolchain. So a modular testing solution provides a lot of possibilities to adapt and to grow with our requirements and our needs. This is a very significant advantage compared to an integrated solution. So before buying a testbed, please always carefully evaluate if a cost-effective and compact integrated solution is sufficient, or if the added value of upgradability makes a modular testbed more attractive. So what are the main takeaways of my presentation? There are many ways to accelerate development and validation of fuel cell systems. So first of all, by using a consistent product development toolchain. We at AVL offer a toolchain that is consistent from simulation to testing, from component to vehicle. Secondly, by applying advanced development methodologies, and I showed you an example of a co-simulator application where we interfaced models of missing powertrain components to the prototype on the fuel cell system on a testbed. And last but not least, please keep the bigger picture in mind when deciding about investments into fuel cell testing solutions. Sometimes an integrated solution is absolutely fine, but sometimes it makes sense to invest into a modular, upgradable, and future-proof testing solution. This concludes my presentation. If you want to get in touch with AVL, please find the contact details of AVL's business manager for fuel cell instrumentation test systems in Korea, as well as my contact details on this slide. Thank you very much for joining my presentation. I hope it was interesting, and I hope we will have a chance to meet in person next time.
철강, 방산, 해운, 상업용 차량 및 발전, 지금 언급된 산업들을 포함한 주요한 산업들은 배출가스의 상당 부분을 내보내고 있습니다. 전 세계적으로 말이죠. 따라서 탄소 배출 제한에 대한 전 지구적 필요성이 증가하고 있으며 이로 인하여 수소는 전례 없는 사업적 추진력을 받고 있습니다. 이것은 재생에너지의 비용 감소에 의해 추진력을 받고 있으며 최근 66개의 국가가 2050년까지 순 배출 제로를 목표로 발표하였습니다. 수소는 성공적인 사용화가 입증되었으며 상업화를 위해 시장 규모를 늘릴 준비가 되어 있습니다. 산업계 리더들과 각 나라의 정부에서는 운송, 산업, 건물 및 에너지 부문에 탈탄소화를 가능케 하는 수소의 능력을 이미 인식하고 있습니다. 그러나 수소가 다른 에너지원과 경쟁하기 위해서는 빠른 총 소유 비용의 감소가 선행되어야 합니다. 현재는 건강과 안전, 그리고 환경 영향에 대한 수소 국제 표준 및 현지 규정이 제정되고 있으며 각 정부는 녹색 수소로의 전환을 촉진하기 위해 지출되는 자금이 시민들의 일자리 창출에 도움이 된다는 확신이 필요합니다. 연구 결과에 따르면 수소 생산 규모 확대는 특히 그 구성 요소의 생산과 유통, 제조 비용 절감에 있어 가장 핵심적인 요인이 될 것이라고 말합니다. 일례로 수소 생산을 위한 전기 분해 용량 증가를 통하여 비슷한 수준의 전기 분해 생산 비용 감소를 가져올 수 있습니다. 그러나 사용자의 총 소유 비용을 줄이고 고객의 요구 사항을 동시에 충족하지 못하게 된다면 초기 투자 비용은 만족할 수 있지만 이와 대비되는 또 다른 숨은 비용이 발생할 수 있습니다. 이것은 사업적인 리스크로 작용할 수 있으며 경쟁력과 수익성 약화를 초래하게 됩니다. 뿐만 아니라 생산 규모를 확장함에 따라 효율적인 생산을 위해 생산량 증가와 생산 비용의 감소, 운영의 간소화를 동시에 이루어야 합니다. 이것은 사업에 있어서 매우 도전적인 일입니다. 시장은 빠르게 성장하고 있고 사용자 및 법적 요구사항이 다양해지며 이와 동시에 비용을 줄이기 위하여 운영을 간소화해야 하기 때문입니다. 우리가 접근해야 하는 방식은 자산의 수명주기 전반에 걸쳐서 총 추가 이익, TPA에 초점을 맞추는 것입니다. 설계, 구매, 설치에서부터 서비스 및 장비 폐기에 이르기까지 말이죠. 이는 솔루션과 서비스가 비용 및 수익성에 미치는 영향을 정량화하는 것입니다. 이를 통해 결국 당신과 당신의 고객 모두에게 수소는 경쟁력 있는 대안이 될 것이고 고객은 빠른 투자 대비 수익을 얻을 수 있을 것입니다. 이것은 더 나은 세상을 밝히려는 우리의 목적과 일치합니다. 수소 시장 내에서 솔루션을 만들어 운송에서부터 철강 생산에 이르기까지 산업의 탈탄소화와 함께 에너지 소비와 비용을 절감할 수 있도록 지원합니다. 크래프트 파워콘에 대해 자세히 알아보겠습니다. 크래프트 파워콘은 산업용 전원 공급 장치 분야에서 솔루션, 제품, 서비스를 제공하고 혁신을 주도해 왔습니다. 우리는 현재와 미래 요구사항을 충족하는 안정적이며 친환경적인 그리고 비용 효율 프로세스를 보장함으로써 고객을 위한 가치를 창출합니다. 우리의 비전은 다른 누구도 할 수 없는 방식으로 프리미엄 전력 변환 솔루션을 제공하는 것입니다. 그 어느 때보다 빠르게 변화하는 세상에서 우리는 그 비전을 달성하기 위하여 끊임없이 적응하고 변화하며 새로운 방식으로 생각합니다. 우리는 기능적 솔루션을 결코 포기하지 않으면서도 더 독창적인 솔루션을 찾기 위해 언제나 열려 있습니다. 크래프트 파워콘은 크게 6개 분야에서 활동하고 있습니다. 마린 파워, 선박 평형수 시스템에 통합된 크래프트 파워콘의 정류기를 통해 항상 안전하고 효율적인 시스템 운영이 가능합니다. 무정전 전원 시스템, 크래프트 파워콘의 무정전 전원 시스템은 정전의 위험을 제거하고 중요한 프로세스를 보호하여 고객의 사업을 개선합니다. 표면 처리, 모든 종류의 일반 금속 표면 처리에 대해 매우 안정적인 전원 공급을 보장합니다. 대기 오염 제어, 전원 공급 장치 업그레이드를 기반으로 하는 당사의 고유한 솔루션으로 전기 집진기에 새로운 생명을 불어넣을 수 있습니다. PCB 및 반도체, DC에서 펄스 전원으로의 전환은 품질과 성능 면에서만 우수한 것이 아닙니다. 생산성과 수익성에 막대한 영향을 미칠 기술 변화입니다. 전기 분해와 수소, 크래프트 파워콘은 1970년대부터 광범위한 산업용 수소 생산 분야에 전력 솔루션을 제공하고 있습니다. 오랜 기간 동안 고객과 사용자가 안정적이고 수익성 있는 운영을 할 수 있도록 다양한 전기 분해 및 수소 응용 분야의 세계적 수준의 전력 솔루션을 공급해 온 것이죠. 크래프트파워콘이 신뢰할 수 있는 그린 수소를 위한 전원 공급 파트너가 된 이유는 무엇일까요? 현장 요구사항에 맞는 다양한 표준 플러그 앤 플레이 솔루션과 커스터마이징을 제공하여 고객의 시장 출시 기간을 단축할 수 있습니다. 더 빠른 시장 진출을 위해 고도로 숙련되고 빠른 대응력을 가진 기술 지원팀을 통해서 지원합니다. 우리는 고객이 생산을 확장하고 내부 효율성을 개선해야 한다는 강한 압박 가운데 있다는 것을 알고 있습니다. 크래프트파워콘은 이러한 목표를 달성할 수 있도록 최선을 다하고 있습니다. 크래프트파워콘의 글로벌 네트워크는 고객이 어디에 있든 지원할 준비가 되어 있습니다. 우리는 글로벌 네트워크를 통해 엔지니어링 서비스를 제공하는 동시에 현지 서비스 엔지니어의 빠른 대응을 보장합니다. 지역 솔루션 센터는 긴급 상황 발생 시 가장 중요한 구성 요소의 재고를 확보하고 있으며 필요시 특정 솔루션을 수정할 수 있는 능력을 갖추고 있습니다. 세계적 수준의 트랜스포머 렉티파이어인 파워크래프트는 최고의 신뢰성과 가용성을 제공합니다. 탁월한 효율성으로 애플리케이션에 최적화되고 최대화된 출력을 기대할 수 있습니다. 파워크래프트는 표준화된 전원 공급 장치입니다. 그러나 크래프트파워콘은 강력한 엔지니어링 팀의 솔루션 지원을 통하여 표준화된 모듈을 기반으로 한 완전한 커스터마이징 또한 제공하고 있습니다. 이로써 시장 출시 기간을 크게 줄일 수 있습니다. 뿐만 아니라 크래프트파워콘은 애플리케이션의 가장 높은 전력 밀도를 제공하기 위해 컨테이너화된 솔루션을 제공합니다. 파워크래프트는 까다로운 전해 공정에서 최고의 성능을 보장합니다. 우리는 전력 손실을 최소화하여 고주파 왜곡을 줄이고 유지보수 비용의 위험을 최소화하는 안정적이고 최적화된 솔루션을 제공합니다. 오랜 기간 입증된 사이리스터 기술을 기반으로 설계되었으며 별도의 변압기와 정유기 패널로 구성됩니다. 수소산업에서의 경험은 우리의 핵심 역량 중 하나입니다. 우리는 수소 충전소, 광산 운송, 철강 및 유리 용광로, 터빈 냉각, 수소 압축 및 정화를 포함한 광범위한 산업용 수소 응용 분야에 전력 솔루션을 제공하고 있습니다. 그리고 수년에 걸쳐 크래프트파워콘은 세계 최고의 수소 생산 시스템 업체들과 협력해 왔습니다. 우리에게 지속 가능성을 위한 가장 좋은 길은 보다 혁신적이고 친환경적이며 효율적인 전력 변환 솔루션을 개발하고 공급하는 것입니다. 우리는 침습성 해양 미생물에 의한 바다에 생태계 혼란을 방지하는 밸러스트 수처리에 전력을 공급합니다. 배기가스와 관련하여 우리는 고객이 대기 오염을 최소화할 수 있도록 지속적으로 노력하고 있습니다. 또한 수많은 영역에서 판도를 바꾸는 5G 내 솔루션과 함께 일합니다. 우리는 더 적은 에너지로 금속 마감 표면 처리 단계의 스크랩을 줄이는 보다 효율적인 프로세스를 보장합니다. 무정전 시스템은 최대 가용성을 보장합니다. 마지막으로 크래프트파워콘의 솔루션이 청정 녹색 수소 생산에 사용된다는 것입니다. 크래프트파워콘의 전략은 전체 비용을 최소화하면서 고객과 최종 사용자 모두가 더 경쟁력을 가지도록 하는 수전해용 전원 공급 장치를 제공하는 데 중점을 두고 있습니다. 우리의 목적은 다음과 같습니다. 우리는 더 나은 세상을 만듭니다. 그것을 실현하기 위해 끊임없이 노력합니다. 크래프트파워콘
Hydrogen, the fuel of the future, needs the right technology to make a material impact. For fuel cells with metal bipolar plates, this means an efficient coating with the right properties. Hi, My name is Kristian Hillgren and I work for the Swedish company Impactcoatings at our Korean office in Seoul. And today I would like to talk for a few minutes on how our innovative coating solutions can give fuel cells with longer durability, higher performance, and lower cost. One of the biggest challenges for fuel cells with metal plates is durability. And the reason for this is corrosion of the metal plates. When you put them inside the fuel cell environment, they will corrode over time. You can have metal ion dissolution, you can have buildup of electrically insulating surface oxides, and both of these processes will decrease the fuel cell's power output. And when the power has decreased by a specific amount, you usually define end of life, and there you have your durability. And some years ago, for mobility applications with metal plate stacks, many were happy with about 5,000 hours of durability. But now that has changed. There's a lot of talk about 10,000 hours, 20,000 hours, 30,000 hours of durability. And this is mainly driven, I think, by heavy-duty applications like buses and trucks. So say you have a stack with 5,000 hours of durability and your customer needs 10,000 hours. What do? Well, of course, you can replace the stack after 5,000 hours. But from the perspective of total cost of ownership, this isn't really a good idea. And if you move to 20,000 hours, you would need 3 replacement stacks, and it's just not going to work. So here, of course, coating technology can really help improving the product's performance and durability. Although you would of course have to pay a price for the coating, the total cost of ownership will be much more attractive. At Impact Coatings, we have some unique low-cost coatings completely free of precious metals that have excellent corrosion resistance, excellent electrical performance, and we also have endless opportunities for driving development and future innovations that are needed to match the quickly evolving hydrogen industry. We can also support you all the way from R&D, initial pre-series production, coating service, even up to full volume production where you have your own coating equipment at your factory. If you need test sheets, half plates, bipolar plates, anything really, coatings with unique and tailored properties, please come by and talk to us and we will absolutely do our best to support you. We are located in the Swedish booth just near the entrance. Thank you.
The PGC 5009 represents the best in process analytics for simulated distillation analysis using fast temperature programmed process chromatography. Designed for fast measurement and separation of components up to C36, the PGC 5009 provides accurate retention times and weight percentage measurements required for boiling point curve calculation, enabling optimized process control. Its results correlate with the ASTM methods D3710, D2887, and D86. Oil refining is the target market for the PGC 5009, and we highlight the distillation, conversion, treating, and blending as the target processes. The high speed of analysis and measurement precision of the PGC 5009 enable tight and effective process control for increasing product quality, minimizing undesirable components in feeds, and optimizing production. The refinery challenge is related to process control and how fast they can react for process upset. A small shift in the cut point for any refinery product can cost refiners millions in profits. In the absence of fast and accurate boiling point data, refinery product yields are not optimized and, more importantly, significant profits are lost. Traditional D86 physical distillation process analyzers have been applied to determine the boiling point distribution for process streams ranging from gasoline components to diesel base stocks. Unfortunately, The conventional technologies are not fast enough to update readings as needed for effective process control. Depending on stream composition, cycle time can be longer than 30 minutes. The PGC 5009 has a resistively heated column. By using the resistivity property of the stainless steel column material and an electric potential applied directly to the column effectively becomes a heater, enabling a fast heated up time. After column heat up, a vortex cooler device flows cold air over the column, rapidly cooling it back to the starting temperature. Digital column temperature and carrier pressure control enable repeatability and reproducibility, providing superior process control. This design allows users to obtain a complete stream distillation profile from the initial boiling point to the final boiling point, providing data correlated to the ASTM methods and cycle time 4 to 5 times faster than traditional D86 analyzers. In terms of results, the PGC 5009 can perform the measurements according to the ASTM method D3710 for gasoline applications and for the ASTM method D2887 for diesel applications in less than 5 minutes. The ABB solution delivers an important value proposition to the refineries, as the PGC 5009's short cycle time, tight repeatability, and high information content enables users to use advanced control strategies that increase profitability. Refineries often change cut points to streams to make different products, and a faster cycle time helps to a faster transition, with consequentially to generate less slop or off-spec material. A faster response also ensures a quicker return to an optimized process control after feed changes and process upsets. The blending goes through a planning phase, and this phase generates a starting recipe based on the blended component availability and properties. The PGC 5009 fast cycle time and good repeatability improve control system performance to reduce giveaway and maintain product quality. Gasoline is the major volume of refinery products, so small improvement matter. The PGC 5009 can also play an important role in hydrotreating and desulfurization units, as this is an important step to remove unwanted sulfur from feed streams. Control of the stream's boiling point range is needed to maintain feed and product specifications, as allowing the exclusion of hard-to-desulfurize components from the feed. These units can run under less severe conditions, extending the catalyst life and run length. This is a typical chromatogram of gasoline process sample, where we can run the complete stream distillation profile from the initial boiling point to the final boiling point in less than 5 minutes.
Let's go over to our last but not least, our king of the soft starter, our premium soft starter, the PSTX. The PSTX is our high-end soft starter, our premium soft starter with a lot of built-in functionalities. I'm not going to be able to talk about every function, but I will mention them in when we're looking at the most reliable operation soft starter, when we're looking at application enhanced features, and when we're looking at the flexible communication. I will mention most of the functions that's in the PSTX. But again, we will start off with the technical specification for this soft starter. And this soft starter is for motors that is from mid-size up to large motors, 30 to 1250 amps motors. And if you connect it inside delta, then you can reach up to 2160 amps. So we're talking really large motors. Main voltage, we have two versions here. We have 208 to 600 volt, the standard product, and then we have the 208 to 690 volt version for networks that need 690 volts, like mining, for example, and very often marine application also need 690 volts, and in some cases some water application also. One control-rated supply voltage, 100 to 250 volt. We have 6 frame sizes with 19 electrical sizes. So we cover a very broad spectrum of motors here. It's a 3-phase control soft starter, and we have the built-in communication Modbus RTU, but also we have the optional NE-bus communication. I will talk more about that later. And again, like the PSE, we have all the marina approvals for the PSTX soft starter. And if we're looking at the application, this soft starter can handle everything from normal start to heavy duty application like crushers, fans, big fans, and so on. But if we're looking at some applications like the pumps, fans, and conveyors, we have a lot of application enhanced feature for those applications. And again, we will talk about that on this slide. Starting off with the most reliable operation. This we mean with we have a lot of protection for the motor, so this soft starter enhance the motor to perform the best. We have, first of all, we have the user-friendly display that's easy to navigate. You get a lot of status information. You can see everything that's going on in your system. We're measuring a lot of things in the PSTA soft starter. And also, if you're looking at the display here, we saw the PSE have a optional external keypad, but the PSTX have a detachable keypad. So every soft starter coming with a external keypad in a way, so that is a detachable, so you can panel mount it. Everything is including to be able to do that. And this display itself is rated for IP66 or 4X outdoor rating. That is for the NEMA market, for the US market. Also, if you're looking at, as I talked about motors, we have a lot of built-in protection like electronic overload, phase imbalance, phase reversals, a lot of different protections that help us to protect the motor from failures. If we look at the built-in application enhanced features, then we're talking about for pumps, for example, the pump cleaning function that we can actually reverse and go forward fast to be able to release blockages in the pump. We have motor heating to be able to always start with a dry motor. We have a dynamic brake for example, for sawmills that you need to stop the blade quicker when you're stopping it. So you're increasing the safety around those machines. We have standstill brake for fans, so you can actually hold the fan standing still so it's not moving if you have this kind of back pressure. And so on and so on. We have also torque control and many other features that is enhancing the application itself. And then we have the built-in Modbus RTU like the PSE. So we have one standard solution for built-in communication, but for the PSTX also we have the optional NE-bus modules. We will see that on the accessory also. But here it makes it easy for you to offer the client any protocol that is needed. So it makes it very flexible. So we have everything from Profibus, Profinet, DeviceNet, ETCAT, BACnet, Modbus, TCP, and so on and so on. I don't know, I maybe forgot a few. But we have more or less all the major protocols to be able to communicate with. Again, like the PSE, we have soft start and soft stop, and also torque control for the for the stopping pumps. But we also have another ramp that is a full voltage ramp. If you need maximum torque to start your application, you can actually put a full voltage ramp on, and that means that we will ramp up very quick to 100% to give the motor the maximum torque to be able to start very tough or application that got stuck or something like that. Built-in bypass, like I said with all other products, but we also have a lot of different built-in protection, like current imbalance, like I said, electronic overloads. We have a lot of different digital outputs, relays, digital inputs, PTC, PT100, external I/O. We'll see an accessory again that we can use, and we have coordination type 1 and 2 for the P-Stacks. This is more or less the same as PSE, the ratings, short circuit rating between 35k amps up to 80 kiloamps. And again, we need semiconductor fuses to be able to have a type 2 coordination. And I don't know if we got a question in here, but type 2 and semiconductor fuses, the semiconductor fuses is there to be able to protect the fires. That is the weak point in a short circuit. They will burn up if you're getting too much energy through them. And semiconductor fuses is the only thing that is fast enough to be able to handle this energy to protect the fire stir. That's why we need those for type 2 coordinations. If we look at accessory, like I said, we have the Anybus modules, and what you can see here on the picture, we have the different modules to get different protocols. So it's very easy just plug and play modules to put in. And I already told you about we have Profibus, Modbus RTU, Modbus TCP, Profinet, Ethernet, IP, DeviceNet, BACnet, and ETCAT. So we have a lot of different protocols depending on what segments and what areas you're in to choose from. We have terminus routes to protect the cables. Again, cable connectors for both aluminium and copper cables. But also we have the extension I/O module, the DX111 FBP from Stotz. That will give you more inputs and outputs. So you will add another 8 digital inputs and add 4 digital outputs and 1 analog output. So this makes this accessory very versatile, and you can actually add in even more signals into the soft starter to control.